Let's talk about 39. I got to find angle X. And really, the only thing probably comfortably you guys could fill in was what? 125 here and what? 55 here? Vertical and supplementary, right? Everyone agrees? And then maybe up here, you threw in, what am I, 75? 105, 75. That's really about as far as you could go. You're not finding angle X using those, though. And the reason why is, yes, I have parallel lines, but why don't I have corresponding alternate interior, same side interior? Why don't I have any of those special angles we talked about yesterday? Because this is not a what? That's not a, well, it is, it's a ray, but is it a transversal? No, it only cuts through one. It's got to cut through both to be a transversal. Also, is this a transversal? Is that one a transversal? No. Okay, so I'm kind of stuck. So what I need to do is draw in an extra line that's going to help me out, an auxiliary line. And the best place you can draw in an auxiliary line is right in the middle, parallel to the other two. And it's important to note that auxiliary line does not bisect angle X. That's not a property of it. It's just parallel. That is it. All right, are we ready to go now? So what you need to do now, look at two parallel lines at a time. So I'm going to take my auxiliary line and this bottom here line that are parallel to each other. So let me just show you those two. Okay, everyone good? Now do you see this line here that couldn't help us before is now a transversal? So if that's 125, where else do you want to put? You tell me, because I could go a lot of different ways here. How could I use that 125 to label more angles now? Specifically here. Okay, let me just do it right here. So everyone agree, why is this 125? They're corresponding. Perfect. Meaning they're congruent if the lines are parallel. Can you find the angle next to it? 75, all right? So everyone's good, that angle 75. That's part of the angle I'm trying to find, X. Yes? Everyone see what I have right now? I got 75. If I can find the angle next to it, I got angle X. But it's not 75 because it doesn't bisect. So let's go up to the top two. Maybe.
Isn't it 55? Yeah, I put 50.
Yeah, 75. Who's telling me 70?
Come on, Grace.
And see, now look what you did to the board now. I wrote something drastically incorrect, and now it's just freezing on me. Oh, boy.
Oh, Grace. Sorry.
This looks good on the video, too. If anybody's watching at home. Yeah, I know it's not. There you go. It's not responding. Close. Good. Let's open it back up. Hopefully I can get that same thing back so I don't have to draw everything over again. Let's see. Where is it? No, that's my other class. My other class. All right. Got rid of the 75. So we're okay here. 125 and now 55. We're good? Okay, now let's look at these two right here. 105, right? Why is this one also 105? Corresponding, right? That's also 105 because they're corresponding. What's the angle next to it?
That one's 75.
That one is 75, yep. Now what can I do to the two? Add them up, 75, 55, buck 30 for angle X. All right, everyone see the advantage of drawing the auxiliary line? Now these lines here become actual transversals when I do that. So that's why I want to draw an auxiliary line. All good here? Yes.
Can you number 15?
Okay, hold on one second. Actually, let me say 45 to the end. So yes, I'll do 15. 15, angle 6, find angle 6. All right, so let's see, what did I have here? Angle 11 was 62. Angle 14 was 38. And then find angle 6. All right, I don't know how you guys want to approach this here, but angle 6 and 14. Anybody want to tell me the relationship between 6 and 14?
What number is that?
This is number, I'm doing the whole beginning here, and the question was number 15.
Corresponding.
They're corresponding, aren't they? And if the lines are parallel, what should I know about corresponding angles?
They're congruent.
They are congruent, so that also should have been 38. All right. Corresponding. Now look, that's just, again, one way to get there. I could have probably went a couple different ways as well to get there. All right, that's just one way to get there. Those are corresponding angles, 6 and 14. Anything else before I get to 14? Yes. 19 to get to angle 1. Okay, let's see. Okay, so let me go from the 62 angle now. Do you agree that 4 and 11 are corresponding? 4 and 11 correspond to each other. Okay, so if that's 62, this is 62. We're good so far? And then you're looking for which one? Which one did you ask me for? Angle 1. Okay, angle 1, 62. Well, okay, I didn't even need to find 62. 38 and 38 from the last problem, right? Because they're corresponding. What's the relationship between 6 and 1 now? Vertical, so they have to be congruent.
For the reasoning, could you have written vertical angles are congruent?
That's fine.
Okay.
Yeah. Yeah.
Like that.
You okay? Anything else before we get to the big one? All right, you better buckle up then. Here you go. And very serious, all the jokes aside, factoring is something that is in geometry that comes from algebra. That is nothing I am going to shy away from. Future homework, tests, and quizzes could have factoring on it. Absolutely. We do a ton of factoring this year, even though this is geometry. All right, a ton. All right, so here you go. Let's see. Find x and y. Well, what do you know about x and 8y minus 15? Okay, do I really want to add them and set them equal to 180 though? Why not?
Because there's two
Yeah, we don't want two variables. What do I know about y squared and x from yesterday? Because they're same side interior. Do I really want to do that? What's the only thing I could realistically do here that's got the same variable in it? Go ahead, Nira.
Y squared equals 8x minus 15.
They're what type of angles?
They're alternate.
Alternate interior. So I set them equal to each other because alternate interior angles are congruent. That's the only thing I can realistically do that only has one variable in it. So everyone good with the setup and y? That's the geometry part right there. Right here, take a look. This is the geometry part. Alternate interior angles are equal. Now the algebra takes over. I warned you have to factor, but you cannot factor unless one side's equal to what from last year? I can't factor this right now. You can only factor if one side's equal, Kevin? To 0, correct. All right, so I need to make one side equal to 0. Now, you look at my y squared. Is it positive or negative? I love that, and so should you. If your squared term is negative, that's a big problem. I feel uncomfortable handling a squared term that's negative. So I'm going to move the 8y over. How? Y squared minus 8y, and I'm going to move the negative 15 over. How? Plus 15. All right, so everyone see why I moved all that over. I did not move the y squared over because if I did, it'd become negative, and now I'm uncomfortable. Are you ready now? Now look, when I say factoring is a big part of this course, I'm not talking every method of factoring either. Basic factoring I'm talking, which is this right here. Two numbers that do this and do this. Multiply to and add to this. Two numbers that multiply to what? 15, but add to negative 8. That's on you now. That's on you. Okay, that's on you. Why? I need two numbers that multiply to 15 but add to negative 8. Kevin?
Negative 3, negative 5.
Negative 3, negative 5. Everyone see how they both add to negative 8 and multiply to 15. That's the type of factor I'm going to ask out of you guys this year. right? For now, anyway. That's the type of factoring. You did not solve for y yet, though. From here, now you set each of them equal to 0. Y minus 3 equals 0. Y minus 5 equals 0. One value y could be 3. Or another value y could be 5. So you actually have 2 y possibilities. But it also said solve for x, right? Find x and y. So that's why you had y equals 3 or y equals 5. Well, how do I get my x values now? How do I figure out what my x's are? I have y's now. Could be 3 or 5, but how do I get my x's? Ooh. Tim?
Plug them into subtract.
Okay, ready? What was one y value? 3. Ready? Plug in 3. What's this angle measure? 9 degrees. Right? What did you guys told me this at the beginning. What do you know about these two angles? Same side interior, so they're supplementary. So if that angle's 9, what's x got to be? 100 and? Okay. So when y is 3, x is 171. Y could also be 5, though. So what's this angle now? 25. 5 squared. Now what's x have to be if it's supplementary to it? 155. So when y is 5, your x value would be 155. That's why there was 2 possibilities of x and y's. Whew. Questions? It's getting serious. It's not like addition substitution days, huh? Anything on this problem here? Factoring is a big part. It won't go away. Anything? We're okay on this. And again, this is about the level I'm going to have you factor right here. 2 numbers that multiply to this and add to this. I'm not going to get any scarier than that. We're all good? Okay. Let me see what you did. And then, yes, I know you're excited. We're back to statements, reasons. I could tell the excitement in the room already. We are back. But now we have parallel lines in our proofs. What can we do with them? So today, all these proofs will give you parallel lines, prove something's true. I want to try to make it clear, and it gets annoying. Those theorems, facts from Unit 2, we will use right now. They're not going anywhere. We still need their help. All right, so I tried to do an easy one just to break you in with these. All right, I set up all the statements. I just need all the reasons from you now. All right, so I'm telling you A parallel to B. Oh, A parallel to B. What can we put on our diagram? From yesterday, what can we put on the diagram? A parallel to B. Let's roll. Arrows, yep. I don't care which way they go. A parallel to B. C is also parallel to D. So how you want to mark those, you can mark them going up, down, double arrows if you want to make sure it's those 2 that are parallel. Up to you. All right, ready? Why in the world then would 1 be congruent to 3? First thing I want to establish why this is not a 2-step proof. 1 and 3, are those any of the special angles we talked about yesterday? When I say special, corresponding, alternate interior, same side, alternate exterior, same side exterior. Are 1 and 3 any of those we talked about? Anything? Well, they are interior to C and D, but are they on the opposite sides of a transversal? They're not, so that's why they're not alternate interior. So is everyone agreeing they are not special types of angles? That's why this is not a 2-step proof. All right, so how do we get there? Here's what I'm stating in number 2. 3 and 2 are supplementary. Why? Look at 3 and 2.
Because
You gotta make sure, you gotta know what type of angles those are.
Parallel lines and.
They're just what type of angles first?
Oh, same
Same
side.
side.
Everyone agrees, same side interior? So from yesterday, they should be congruent or supplementary. That's why I said they were supplementary, because they're same side interior. And hopefully this is go smooth today, because as annoying as it probably was, it's worth it today, because we wrote down all those justifications yesterday for this reason. Parallel lines imply what type of angles?
Same side.
Same side interior angles. You can't just stop there, though. You got to tell me something about them. Are supplementary. Everyone's good. Stop me here, because it's only going to get tougher today. Stop me. All right. Now I'm telling you 1 is supplementary to 2. Why? 1 and 2 are also supplementary.
Same side interior.
Aren't they same side interior as well? Yes, no, maybe?
Yeah.
For C and D, parallel line C and D, they're same side. So same reason. Parallel lines imply same side interior angles are supplementary. And here's where the fun stops. That was pretty easy for a lot of us. Now you got to use everything. Everything. I keep pointing to a blank board, but you know what I mean. All right? Everything. You can't use any more parallel line facts now. Why is 1 congruent to 3 based on, yes, something from the past? Matthew?
Supplements at the same angle on again.
Look at 1 and 3. Ready? You guys don't see it. What did I know about angle 3? Supplementary to 2. What do I know about angle 1? It was supplementary to 2. 3 and 1 are both supplementary to the same angle. All right? That's where we need to keep using this stuff. Yes.
So why can't we do substitution?
Okay, substitution's only for equal quantities. Okay, equal quantities, and I don't have any equal quantities up here. If you do this, here you're going. If I do 3 equals 2 and 1 equals 2, yeah, we can do 1 equals 3 substitution. But that's only for if things are equal. I can do substitution.
Oh, right.
These are supplementary. I can't do it for words. Supplements of the same angle are congruent. So now you know what I'm talking about. Yes, now we're using parallel line facts in addition to everything, the building blocks from Unit 2. Anything you want to ask about this proof? How could it be done differently? Could you have switched steps 2 and 3 and still been correct? Yeah, you could have. Hey, even if you want to put steps 2 and 3 into the same step because it's got the same reason, that's fine too. Questions here before we do a blank one here. No statements I give you on the number 2. All right, ready? Think they're ready, Lucy? Think they're ready? We'll see. And it's okay to feel uncomfortable and think that it's tough. I get it. These are a lot tougher than the ones we did last unit. All right. I see some of you guys marking your diagram. Ready? AD is parallel to FB. I can get arc marks out on CDA and BFE. Why are CDF and DFE congruent? Also, the days of two-step proofs are over, so, okay, they're over. Over. Okay, I'm sorry, they're over. Plus, you guys know you're going to use the given, so why do you even bother? All right, giving you these angles are equal if I'm never going to use them. You're going to use them. All right, let's start with the parallel lines first. The reason they gave me parallel lines was, hey, look for a special type of pair. Here's the thing, though, and here's where we're going to start getting confused. When you give me the special pair, they better have AD part of it and FB part of it. So when you tell me angle, boom, 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 they better have AD or FB as part of it as well. So does anybody using AD and FB, do you see any of the special types of angles in that diagram that could be congruent or supplementary? Do we see any right there? You ready to roll, Reagan? Go ahead.
Yep.
Go.
So ADF and DFB.
Stop. Just stop right there. ADF and DFB.
Alternate interior.
They are alternate interior. Do we see that? Now look, here's what I was just talking about in case you were confused. ADF. Watch. Please watch. ADF. That contains what parallel line? AD. It should. BFD contains what parallel line? FB. So when you guys give me these angles, they should have the parallel lines in them. Do you see ADF has AD? BFD has BF. And, ready? Whoa! Don't they have a line in common? What line segment do they both have in common? Which is a what? Transversal. Okay, so when you tell me the special angles, they should have the parallel lines and a single transversal in common. You're going to start seeing that and understanding that a little bit better as we move on. ADF is congruent to angle DFB. This is what we wrote yesterday. What do you think the reason is going to be?
Alternate interior angles are congruent.
No, they're not. They're not congruent unless you have what?
Parallel lines.
You got to have parallel lines. That's why this needs to be there. Alternate interior angles are just alternate interior angles until those lines become parallel. Now they're congruent. All right, I got a lot of mess up here, so let me clean it up here. These were parallel. We just said these were congruent, and these were given congruent. Anybody see it now? Anybody see how I'm going to get CDF and DFE? Something from Unit 2 now? What am I going to do with these given angles and alternate interior angles to get the bigger ones? Addition. Wait, what'd you say? What'd you say? Addition? Wait a second. Don't you need two pairs of equal quantities to add? Do I? Where's one pair?
CDF.
Given. Where's the other pair?
ADF.
Your alternate interior. Okay, good. I'm just making sure. Still need two pair. And yeah, it's the givens and the alternate interior angles. So angle, let's see, CDA plus angle, what am I adding to CDA? ADF equals angle BFE plus DFB. Addition. And you know what's not changing though? After we write addition, substitution. Yep. I promised you that. Anything you want to ask? Two-step proofs are over. Ask away. I know there's only one more, but These are tough to get a handle on right away. Ooh, hoo, hoo. Anybody eyes lighting up yet? As you take a sneak peek at the Givens? Anything going through your mind right now as you look through the Givens?
Bisect.
How many times? How many angles? Whoa! I'm bisecting 2 angles, guys? I've sniffed that before. Definitely have sniffed that. What's your deal, Matt?
My shelf and my pencil.
What?
My shelf and my pencil.
You don't have to ask, it's fine. Ooh, oh! Anybody have something in their mind, possibly, what's going to be used? Even before I look at the diagram and I see I'm bisecting 2 angles?
Quantities are equal.
Oh, yeah, remember those? Halves of equal quantities are equal, right? When I bisect 2 angles or 2 segments, yeah, good job. Not going to be 2 steps though, right? So can we all agree, class, we got halves of equal quantities on our hands. All right, let's go through the checklist. What do I need first to use halves of equal quantities?
2 equal.
Yeah, I need equal quantities. And in unit 2, you guys were lucky because I always gave you those. Do you have equal quantities here? No. Do you know what I'm going to take half of? Yeah. What 2 angles am I going to take half of? JEB and EGD. Look at those angles on the diagram. Tell me something about them. They're what? Aren't they corresponding? JEB and EGD? All right, so what do you know about them then? They're congruent. Those are your congruent quantities, yeah. What you're going to take half of need to be equal before you use halves of equal quantities. JEB congruent to EGD. Why? Oh, here we go. Yeah, now we're talking my language. Parallel lines imply corresponding angles are congruent. Yeah, yeah. Okay, now you have equal quantities. What are you guys going to do to these equal quantities? Okay, ready? Half of, what's one angle we're going to take half of? JEB equals, look at your diagram. Out of those 2 angles, which one do I care about? JEF or FEB? Yeah, why, Maddie?
Because that's what we need to prove.
It's in the darn proof statement. All right, let's keep grinding. That's not the only angle I'm going to take half of. I'm also going to take half of EGD. And that'll be angle HGD. What's my reason going to be here? Watch yourself. Yeah, bisect. The bisector told me you were going to take half of those angles. Yeah, definition of bisector. All right, checklist ready. Do you have equal quantities you're going to take half of?
Yeah.
The corresponding angles. Did you take half of them? That's step 3. Now you're good to go. Now you can tell me those halves, FEB and HGD, are congruent. Halves of equal quantities are equal. So the only difference now between this one and unit 2 is in unit 2, I usually just gave you that right off the bat, that those are equal, what you're going to take half of. Now you got to tell me why they're equal. So that's really the only difference. What you're going to take half of, why are they equal? Questions? Perfect. You guys got over 10 minutes right now to practice on your own, talk in your group. All these answers are up on Classroom. Now, I do want to just point out one thing, especially when you get to like proof number 2 tonight. I did it one way on Classroom. Ready? That's not the only way. A couple of these proofs have multiple ways of doing that. All right, so if you think you did it right, bring it to class tomorrow. I'll take a look at it and see if you're right, if it doesn't match mine. Here we go. Let's get rolling. Call me over if you're stuck. You guys got